Education is the key to a bright future. empowermefirst.college.
Before, we have talked about the natural numbers and the whole numbers and the integers. What if now I took the portions that I was talking about in the previous video? This means in the previous video I showed a house here, and I showed a hospital which was 10 kilometers away and a school which was 5 kilometers away. What if I have something here, this is 4 and this is 5, that is located in between 4 and 5. It is somewhere here. In this case, I have to talk about the decimals. And simply decimals are portions. That means I have $8 and 23 cents. What I do is I write it as 8.23. When we talk about these decimals, there are two groups of these decimal numbers. The two groups are, first group of decimals is the group where the decimal number terminates. That means after the decimal point, we see the number ends, like 2.8. What comes next are zeros, that I call them trailing zeros, and I can just ignore them. Or 5.08143, and I stop. These are called terminating decimals because they are decimals that have a limited number, a finite number of digits, and they stop. There are the unlimited decimals, the non-terminating. First part of unlimited decimals is unlimited repeating decimals. What does this mean? There is a group of decimals that I can write as 5.636363 forever, or 0.44444 again forever. This is unlimited decimal. It never stops, but actually it makes a pattern. It repeats itself later. 63, 63, 63, 4, 4, 4, 4. Another group of the numbers in the real number set, the unlimited non-repeating decimals. Unlimited non-repeating, they are non-repeating and non-terminating decimals. These numbers, like this piece that you see, which I call the radical 2, the pi, the e. Pi, for example, is equal to 3.1415 blah blah blah. You can use the Google search or a calculator that gives you a huge number of digits after the decimal point, and you can see pi for a long time. The first one who discovered something for pies discovered almost 2500 digits long time ago, and he gave up. But nowadays computers can give you up to millions of digits after the point. This non-repeating and non-terminating decimal will be called, that set alone will be called irrational number. They are, by the way, I repeat, all of them are real numbers, but this piece is the piece of irrational numbers. So what about the remaining two pieces? I will call them rational numbers. I will stop at this part because this section we will go over it in details later on in another unit when we use fractions and we convert decimals to fractions and fractions decimals. This unit focuses on just giving some definitions. Now, going back to the integers, and actually I will stop at the positive integers only, although I put some negative integers here, but I will try to limit these two definitions on the set of positive integers only, which is very simple and everyone knows it. Some numbers can be divided into two equal pieces. Some numbers cannot, like 1, 2, 3, 4, 5. I cannot divide it into two pieces. If I will divide it by 2, I will get 2.5 each time. But if I take 6, which is very simple, I can simply make it two pieces. I say 6 is divisible by 2, 5 is not divisible by 2. This set of integers that can be divided into two pieces will have in the first place 0, 2, 4, 6, 8. Examples like 8 itself, 26, 30, exactly, 2534, simply because it ends with 460 or starts with 460. As you want, you can say it, but we will be keeping one terminology in our math course. So I will talk about this as 402 and so on in the beginning. That always I will say the beginning, I mean this digit. These are divisible by 2. I call them the even numbers. So the rest, which ends with 1, or sorry, again, starts with 1, 3, 5, 7, 9, I call them the odd numbers, as you see clearly here. This definition can stop here only. You don't need to know more. You need to know it odd and even.